Today in this video, we will learn how to create a procedural material from scratch. Here we make this clay pot material using Blender procedural textures. Before we start making the material, let's get a rough idea of this. If we consider a normal material, it consists mainly of a color map, a metallic map, a roughness map, and a normal map. These maps give various details required for the material. A color map gives the desired color details for the material. The metallic map provides information on metallic and non-metallic areas of the material. A roughness map describes areas where the material should be rough and non-rough. A normal map gives the details of the height and depth areas required for the material. And these four texture maps combine into one main shader, such as a principled shader, to create a material. So, we will first create the required color, roughness, metallic, and normal maps for the clay material here using Blender procedural texture. After creating that, we connect these texture maps to principled shader and do render. Here we will use a different Blender layout to create this material. This is the layout we use. You can download the Blender file with this layout through the link in the video description below. This sphere in the left side viewport is the demo object that we use to create the material. This comes with a basic lighting setup. Here you can see that only the sphere is rendered in the material view. This is set in the holdout option of the outliner. With this option, you can remove a collection of objects from the render scene and set a black layer for its render area. Here, demo objects and all other objects are in separate collections. So, by holding out the existing collection of other objects, only the demo object is displayed in the material view. In addition to the sphere for the demo object, there is also a clay pot 3D model. Here, the render out of the normal material view is different. This material view is similar to the Eevee real-time rendering. This is done by enabling these two lighting settings in the material view shading settings. Now let's start the material creating workflow here. So, select the sphere and create new material for it. Let us first start by creating the color map of this. The color map we are going to create consists of 5 procedural textures. This means that there are 2 textures to provide the main color details and 3 textures to provide additional details. We will create these color textures in the order shown here. Okay, let's make this texture one by one. Let's create this first texture. So now add a Musgrave texture here. We will use the Node Wrangler add-on to preview the textures here. If you have not enabled this add-on in your Blender, enable it in your Blender preference. Okay, now we have added the Musgrave texture here. Now you can use the hotkeys shown here, click on the relevant texture, and see the preview of that texture. Now let's use this preview output to create the color map we want. Now add a texture coordinator here and connect the object vector out to the Musgrave texture. And add a mapping node to this connection. Okay, now let's set values for this. Set the Z-scale value to 100 in the mapping. Then, change the FBM type of Musgrave texture to Hetero Terrain. And set the scale value to 2.1. After setting the values, now add a color ramp to the Musgrave texture out. Here, for the color values of the first color stop, set the values to 0.059, 0.684, and 0.795. For the second color stop here, set the values to 0.69, 0.416, and 0.862. Now let's start making the second texture. After setting all these, now add another Musgrave texture and connect the object vector to it. Then set a mapping node for this connection as well. Now let's set the node preview to this and adjust the values. First, change the type of Musgrave texture to hetero terrain. And change the scale value to 50 here. Now by reducing the offset value we can get this texture as we want. Set the value to -0.78. Now add a color ramp to the output of the Musgrave texture. Now let's set the color as we want. Leave the first color stop on this color ramp unchanged and change the values of the second color stop to 0.003, 0.967, and 1. After this, let us start working on the third color texture. For this also, we need a Musgrave texture. So add Musgrave texture and connect the object vector to this as before and set a mapping node. Now let's set the node preview and adjust the values here. Set the Z-scale value of this mapping to 7.4. Then change the Musgrave texture type to hetero terrain. After changing it, change the scale, detail, dimension, linearity, and offset values to 57.1, 16, 90.4, 1.95, and -0.78 respectively. Although the preview looks black like this, it has a lot of little details. Let's set a color ramp for this and change the color values. Change the values of the second color stop to 0.008, 0.679, and 1 without changing the first color stop. OK, now let's set the fourth texture. To create this, first, add the noise texture and set the object vector and mapping node as before. Now let's set the node preview and adjust the values here. Here, change the Z-scale value of the mapping to 37.7. Then, change the scale, detail, and roughness values to 16, 10, and 1. Now let's add a color ramp to this and set the color for this texture. First set the position of the first color stop to 0.518 and add a new color stop. Change the position of this to 0.698. Now change the color values of this color stop to 0.044, 0.874, and 0.444. Then change the color values of the third color stop to 0.999, 0.967, and 1. Now let's create the final texture required for this color map. First, add the Musgrave texture and set the object vector and mapping node as before. Now let's set the node preview to this and change the values. Enter 100 for the Z-scale value of the mapping here. Then change the Musgrave texture type to hetero terrain and then change its scale value to 4 and the offset value to -0.63. Now let's add a color ramp to this and set the color. Set the color values of the second color stop to 0.02, 0.889, and 1. We have now completed the 5 textures we need to make the color map of our clay material. All we have to do now is blend these textures one by one and get the output of the color map. Before that, let us set the locations of all these nodes in order. To do this easily, enable the snap feature in the shader editor. Now let's position these nodes. After arranging the nodes, let us now add the mix RGB nodes required to blend these textures. Drop this to the first texture output and change the blending mode to color. Now connect the second texture out to this and give a value of 0.417 for the mix RGB node. Zoom in on the node preview sphere and you can see how these two textures are mixed. You can adjust the blending of these two textures by increasing or decreasing the mix RGB value. Now duplicate this mix RGB node and put it on this connection. Then connect the third texture to this. Give a value of 0.992 for this value. Now duplicate this node again and connect the fourth texture to it. Give 1 for the value of this. You can now see how our color map is created gradually. Duplicate this color node again and connect the fifth color texture to it now. Give a value of 0.4 for this. We have now completed the work of creating our color map. Now let's connect the output of this last color node to the principled shader. This is how the color output of our clay material appears through the principled shader. Now let's arrange all these color nodes. Now let's frame these color map nodes. Here we frame only these nodes as a color map. This is because these textures are also used for other maps that we create here. After framing these nodes, now rename this as color map. Okay, let's start working on the metallic map now. This consists of 2 procedural textures. Before we make this metallic map, let us know how this metallic map and roughness map works. We have previously created the color map required for this clay material. When creating the color map, we wanted to create the color textures that we need for this map and mix them to get the final output of the color map. But there is one more thing we need to know when creating procedural textures for roughness and metallic maps. This roughness and metallic details work according to the black and white color details. You know that the principled shader has a 0 to 1 value frame for controlling these roughness and metallic details. But you may think that it does not show black or white color value to control this value here. That's correct, but there is a connection between these values. So, now let's see the relationship between these 0 and 1 values and these black and white colors. The value 1 indicates the color of white here. And the value 0 indicates the color of black for this. Thus, for decimal values from 0 to 1, we can get the corresponding color through a black and white color gradient. For example, 0.5 is a gray color. We call this kind of black and white color gradient a grayscale color gradient. That is why we call these maps grayscale maps. Also, maps that use color are called RGB color maps. Accordingly, color maps are available in this RGB format. You know this when the rough value of the principled shader is set to 1, that material becomes fully rough. So, for example, when we use a roughness map to set roughness details of material, the places shown in white on the roughness map are fully rough on that material. All the places are shown here in the black color are none rough on the material. And gray areas show the mixed area of rough and non-rough material qualities. Also the same, on a metallic map, white color show the metallic area of the material, and the black color shows non-metallic area of the material. And gray areas show the mixed area of metallic and non-metallic material qualities. Let us now make the first texture of this metallic map here. So, first, add a noise texture to this and set the node preview for it. Then, as before, connect a texture coordinator and a mapping node. After connecting them, change the scale value of the noise texture to 13.7. Now let's add a color ramp to this and set the texture. After adding the color ramp, now change the interpolation of this color ramp to B-spline. Then set the color value of the first color stop to 0, 0, and 0.18. Now set the position of this color stop to 0.768. After setting this color stop, now change the color values of the second color stop to 0, 0, and 0.205. Okay, now let's make the second texture of this. First, add a Voronoi texture to this and connect the texture coordinator and a mapping node to this as before. Now set the texture preview to this and change the values here. So, first, change the feature output of this texture to smooth F1. Then change the scale value to 6.08. After changing the values here, add a color ramp to this Voronoi texture out connection. And then add a color invert node to this connection between Voronoi texture and color ramp. Now change the interpolation of this color ramp to B-spline. And here, set the position of the first color stop to 0.249. After that, change the values of the second color stop to 0, 0, and 0.058. Now we have created the two textures required for the metallic map of our procedural clay material. Now, all we have to do is blend these textures and generate the metallic map. Here, we can use add blending in the mix RGB node to blend these two textures. But as we said earlier, since the output, after creating this map is in grayscale color format, it is better to use math nodes instead of mix RGB nodes. The add function of both these nodes gives the same output. But for the above reason, connect these two textures to the math node and get the output. Right now we are done creating our metallic map. Now let's arrange these nodes. After that, frame these nodes related to the metallic map here. After framing the node, now rename this frame as a metallic map. Now connect this metallic map to the metallic value of the principled shader. Now you can see the preview of our clay material with the metallic map. Okay, now let's start creating the roughness map of this material. This roughness map consists of 3 textures. And here for this roughness map, we will use the procedural textures nodes we created earlier. Okay, so now, to get the connection of these 3 textures, first, add 3 color ramps here. Now let's connect these 3 textures for these 3 color ramps. According to the order of these nodes, we need the 2nd, 4th, and 7th texture nodes here. Okay, now connect these textures to these color ramps in order. After that, now let us set the values for these color ramps. Here, leave the first color ramp unchanged. On the second color ramp, set the position of the first color stop to 0.141. After that, select the third color ramp and enter the color values of the first color stop as 0, 0, and 0.126. Then give 0.459 for the position of this stop. Now, select the second color stop of this and set the color values to 0, 0, and 0.545. And then, change the interpolation of this color ramp to B-spline. We have now finished preparing the textures required for our roughness map. Now blend these textures and get the output of the roughness map. For this also, we use math nodes. So, first, add a math node here and connect these 2 color ramps to it. After that, add another math node here. Change its function to multiply and set this on this first color ramp connection. Here, we can multiply the value of this texture by a negative value using this multiply math node. We can also do the same operation as we do use these 2 nodes, using the multiply add function of this math node. So, add another math node here and set its function to multiply add. After connecting these textures to this, you can see that the result given by these nodes are the same. So, now keep only this multiply add node for this and give -1.25 for the multiplier value here. After that, set a math add node to this output connection here. And connect the third color ramp to this math node. Now for this third color ramp connection, set a math multiply node and change its value to 0.6. Right now we have created the roughness map for our clay material. Now let us arrange the nodes properly and frame them. After framing this, rename this frame as a roughness map. Now let's set this roughness map frame between this color map and the metallic map. And arrange all other node positions. After positioning all the nodes correctly, let us now connect this roughness map to the principled shader and see how it works with our material. Now you can see the preview of our material with the roughness map. Okay, now let's make the bump map for our procedural clay material. When creating procedural material, we cannot create a normal map directly here. But we can generate a bump map using these procedural textures, and then we can convert that map into a normal map output using a bump node. So, let us see first what this bump map is. A bump map shows the depths and heights of an object material. So, here the heights are shown in white color, and the depths are shown in black color on a bump map. And gray colored areas are between the height and depth values. And here, you can see this map also keep the same rules that we learned earlier for the roughness and metallic maps. So, this map is also a grayscale map. Let us now create the bump map for this material. This bump map consists of 4 textures. Here, we will also use the textures we created earlier. So let us get started creating this map. According to the order of these nodes here, we will use the first and second textures and the last texture of these textures. We will use this first texture twice here. So, now add 4 color ramps to connect these textures. After adding these, now connect the first texture for the first and second color ramps here. Then connect the second texture to the third color ramp and the last texture to the last color ramp here. After connecting these, let's set the values for these color ramps. Here let us first set the values of the first color ramp. So, change the V color value of the second color stop to 0.06. Now set the node preview for the second color ramp here. In this ramp, change the first color stop position to 0.568. And then select the second color stop and change its V color value to 0.2. After that, now set node preview to the third color ramp. In this ramp, change the V color value of the second color stop to 0.11. Now finally select the fourth color ramp and change its interpolation to B-spline. After changing that, now set the node preview to this ramp and change the values. In this ramp, change the V color value of the second color stop to 0.052. Right now we have finished customizing the textures as we want. Now let's blend these textures and get the bump map output. So, now set the node preview to the first color ramp here and add a math node to this connection. After adding that, connect the second color ramp to this math node. Now, add 2 more math nodes to these color ramp connections. Then change the function of these math nodes to multiply and give a value of 0.1 for these 2 nodes. After that, now set the node preview for the third color ramp and add a color invert node to this connection. Now add a math node to this connection and connect the above node to this math node. And then add another math node to the output connection of this color invert node and set its function to multiply. After adding this, give 0.2 for the value here. Now set the node preview to the fourth color ramp. After setting the node preview to this, now add a math node to this preview connection and connect the above node to this math node. Then add a math node to this last color ramp connection and change this to a multiply function. Leave the value of it unchanged. We have now generated the bump map of our clay material. But to connect this map to the principled shader, you need to connect this bump map to a bump node. So, now add a bump node. And connect this map output to the height value of this bump node. After connecting this, now you can set a node preview for this bump node and see how it works. Here, enter 0.5 for the strength and distance values of this. We have now created the bump map of this material. So, now arrange the position of these nodes and frame these nodes. After framing this, rename the frame as a bump map. Now finally place all these maps so that they can be connected to the principled shader. After that, now connect the principled shader to the material output and change the viewport to rendering to see the final output of this material. After arranging everything, now connect this bump node to the normal value of the principled shader. Here is how this material is viewed on the cycles rendering. Let's see this material view in the EV engine. You know we changed the option in the material view of this project to get the EV preview. So using this view, let's see the EV preview here. After all that, now let's see this material on a pot model. You know that there is a clay pot model in this project file. Now let's apply this material to that pot model here and see how it works. So, hide this demo sphere. We now need to provide this material for the pot model here. So, unhide the pot model and select the clay pot material for this. After selecting the material, now you can see the clay pot material through this pot model. This is how it looks from the EV render view. Now let's see this in the cycles rendering. After all, let's set a camera for this and render this. So, add a camera here. You can set the viewport view to the camera view using the hotkeys shown here. After setting this camera, go to the output properties and swap the X and Y dimension values here to each other. Now, zoom out the camera and adjust it to fit this pot exactly. Now let us set the render border to this and then set render settings for this scene. Now adjust the sample size to 500 here. Here, by using adaptive sampling you can avoid taking render samples unnecessarily through the render process. Here we do not use any render denoising to get the correct details of the material for the first time. The tile size here should be in line with the rendering device we are using. I will use both GPU and CPU devices to render here. So, I have to give the tile size that fits the CPU rendering. If you are only using a GPU for rendering, your GPU tile size should be 128, 256, or 512. You can enable the GPU setting for the cycles rendering through Blender Preference. If both your GPU and CPU support cycles rendering, CUDA device selection will show both your device as options. By enabling those two options you can render using both GPU and CPU devices. After setting that, now you can select GPU compute for render device here and get start rendering. I will use both GPU and CPU devices to render here. So, I have to give the tile size that fits the CPU rendering. Okay, now let's render this. Before that, disable the rendering of this demo object which we used earlier to create the material. Now let's render this. This is the final output of our procedural clay pot material. It took 2 minutes and 47 seconds to render 500 samples of this material. Here it is common for procedural materials to render so slowly. This is because the GPU and CPU have to work hard to generate and render all the details in this material. But by baking the color maps, metallic maps, roughness maps, and bump maps created by these procedural textures separately for images, the render process time can be reduced by more than 3 times. So, we can bake this material's texture maps for this clay pot model and use it to render this faster. We will do this baking part of this material in the next part of this video. So for now, use this material for your works and tell us how this works. I hope you have learned something new from this video. If you like this video, hit the like button. If you want to watch more videos like this, subscribe to our channel, click on the bell icon on the side, and select all. This will allow you to receive notifications for future uploads. If this video helps your Blender work in any way, don't forget to comment on how. If you have any other issues with this video, please comment as well. And if you would like to support us, please share this video with the Blender users you know. Learn with IBN.